Welcome to the Quantum World TV, and this morning we have a special guest, Nassim Haramein, and this will be a very special emission, and thank you to be with us this morning to share this information, not new information, but very actual information about the structure of the universe. This will be a morning where we will again push the frontier of understanding of human being, because for us at Quantum University it's something that is very dear to us, how to understand the mechanic of how works the brain, the mind, the body, and not only that, to give this scientific foundation of what I call a new curriculum for modern medicine. And Nassim you are very special. If I look at your journey,
yes.
Born in Geneva, and yesterday I realized you live also in Canada.
Yeah, most of my childhood.
And probably one of your most important trait or feature in your curriculum is he speaks French.
Yes.
Not only that, he speak Quebecer, so
Yeah,
that's something we have in common.
Yeah, I can speak Quebecois.
And sometimes I say, you know what, God doesn't speak maths, he doesn't speak quantum physics, he speaks French. Because this is the language of love. So.
Oh, that's right.
But we will see in a few minutes that he also speaks fractals, right?
That's right. Maybe French fractals.
French fractals. So he born in Geneva, and already at the age of 9, he had discovered the universal dynamic of matter and energy. So I think you were very,
I was thinking about it, definitely.
And I saw you online explaining, how you were even challenging teacher at that time.
Yes,
and,
yes.
So it's pretty amazing.
It got me in trouble
plenty
of times.
And today he's director of research and the Resonance Project Foundation and the Hawaii Institute for Unified Physics, where he leads a team of physicists, electrical engineers, mathematicians, and other scientists to explore the frontier of unification principle. And I was very amazed, when I look at some information that is online. So, you predict many events, and when I'm looking at the story of Einstein, he has this story where, Heidelberg,
Yes.
who, done one prediction, and the whole world was excited.
Right.
And in your itinerary, more than 80 prediction.
Yes.
And now it brought me to speak about, the last one, which is a major discovery. You publish a paper.
Yes.
Predicting the mass of the proton. And what also impressed me, one day I was listening at online, and you were saying it's not about trying to find the smallest tiny particle, it's about to look at the pattern of information.
Right.
And it's so true, even in healing, when we look at an individual, and more you look from this holistic point of view, you have to gather some more information, but you have also to organize in a fractal way. So,
right, look at the pattern of the
So we have probably something in common there.
No
but
doubt.
let me, I'd like you speak more about this article you wrote, and I think it's very important. It's also a cornerstone, how to explain universe,
Right.
how this work,
Yeah.
the mechanic, and I'd like you comment about that.
Yeah, it was really exciting. First of all, thank you for having me.
That's my pleasure.
And yeah, it was really exciting, after all these years of researching and, trying to find some of these fundamental equations. I had found like some of the patterns early on and, trying to express them in mathematics. And, when you write the mathematics, it starts to lead you and you go down these roads and some ends in, in dead ends, and then some, continue on. And when I got to that point where it kind of unfolded like a flower, and it was so simple, it was so easy, it was so clear, it just blew my mind. After some 25 years of doing such complex mathematics and physics and all this, for it to like unfold into this so simple geometric pattern, which gives very, very precise result for the mass of the proton, as you mentioned, and for the strong force and for the radius of the proton, which is really important because the proton is a fundamental particle from which all matter in the universe is generated. And so the measurement of the radius of the proton has been a big difficulty for many years. It's extremely small. You're talking in the very, very, very tiny particle, 10 to the minus 13 centimeters. It's extremely hard to measure.
This is very small.
Yeah, and so it was a big issue for a long time to try to get a really precise measurement of that radius. And from the theoretical mathematics I wrote, all of a sudden it came out, and it was very, very precisely close to the latest measurement that was done in 2010 at the time. And so I included that in my paper, that it was inside the margin of error of the actual best experiment we had at the time. And I published a paper, and within a few months, a new measurement was done in an accelerator in Switzerland, and it was more precise than the 2010 measurement. And sure enough, I was, inside the margin of error of that experiment as well, and even closer to the value that had been found.
So people have to understand that. This is very important. It's like you come with your model of understanding and your maths and calculation, and you come with a number regarding the mass which is more precise than the experiment and what physicists come with their own perspective.
Right. Actually, the standard model is like some 4% off, and although 4% doesn't seem like much, many articles have come out in the more popular press showing this radius of the proton is a big problem in quantum physics right now. And so what's exciting, I mean, the prediction was an amazing thing for it to happen so quickly and be confirmed so quickly. But what's exciting is that what does it mean, Like, what does the theory say? If the theory is correct, what does it mean? And like a very overarching idea of the theory is what it means is that everything is connected through this field of information that is at the base of quantum theory, like below subatomic particle, below everything. There's this field of information that we call vacuum fluctuations that's occurring at the Planck level, which is super tiny. And is these little oscillators, and they're present everywhere in high density, everywhere in the space between us, the space between atoms, between molecules. And they are the relationship of these field of information is what produces the mass that we see as the reality we see all around us.
And you come to that conclusion eliminating the strong force, right?
Right.
That's the...
Yeah, that's the crunch.
the crunch of the whole thing.
Yes.
And to eliminate the strong force, then you design a model where gravity and electromagnetic field are enough, but then it's like the proton has to be kind of type of a black hole or something. Do you want to explain that?
Yeah, actually, the solution when I was writing it, first I applied it to black holes, cosmological black holes. So instead of Einstein described gravity as this surface of space-time curving, like if you were to put a ball on the surface of a trampoline, it would curve the trampoline, and any other ball would like feel attracted because of the curvature of space-time.
Yeah, this graphic is very known.
Common.
It's kind of a classic one.
Right, and so you could think of this curvature as like the surface of water when you pull the plug in your bath.
Yeah,
and like the rubber ducky you have in your bath. I don't know if you have one anymore, but
I know exactly what you're speaking about.
Yes.
So you give a torque to that,
yeah,
right?
And then the rubber ducky starts going towards the drain, right?
Exactly.
And so that curvature is what Einstein described. What I came to describe is that the field of space-time, like would be the water in the tub, is made out of little particles, like the water particles in the case of the tub. And I calculated the water part or the little particles, the little Planck fluctuations of that field, and it give me the exact same answer. So it's like Einstein described the curvature, but this new idea describes all the little particle that makes the vortex. So it's the more fundamental structure of space-time, why space-time is curving, that emerge. And it's curving because there's spin and there's gradient density, just like when you pull the plug in your tub. And when you do that, all of a sudden, when I calculated
And this is what we see on the screen now. This kind of torque and
this kind
spin.
of torque and spin in the structure of space-time, just like water going down the drain. And when I calculated that, it gave the exact solution for gravity, like just as Einstein field equations, but in this case, built on simple fluctuations of the vacuum structure at the quantum level. So this is a new thing. It's gravity described with quantum objects, right?
Absolutely.
This is the bridge that Einstein was looking for, that we've been looking for 100 years, is that bridge between gravity at the cosmological level and quantum theory. And so all of a sudden I thought, wow, this could be quantum gravity. So then I applied it at the quantum level of the proton, the subatomic particle, and it worked out. It came out just right for the mass of the proton, and then I was able to predict the radius of the proton. And then when I calculated the gravity of such an object with that theory, I ended up with the exact force that we call the strong force, that force that holds the protons together in the nuclei of an atom. And I realized, wow, the strong force could be just gravity at the quantum level due to these little fluctuations of the vacuum that are everywhere. And it came out just right. Not only did it come out just right, when I calculated the spin of that force, it gave the exact range that we measure the strong force to be between two protons in the nuclei of an atom. So that all of a sudden simplifies all the model of quantum theory and relativistic relationship to quantum theory to very fundamental level of this vacuum energy, this field of information that's permeating everything, and that mass emerged from, and gravity and electromagnetic fields.
But sometimes simplifying is not this is not what is the most comfortable for everybody. But
that's right.
What I like you speak about is about, we have all this idea of the quantum and probability and intention and innate intelligence. But what the way you carry on this concept is that the information now reside at the core of this torque, right? Can we say that?
Absolutely. And basically everything is talking.
And maybe we should bring some the slide for that. I don't know. Yeah, Mark.
Some of the slides of
showing the protons and the torque and the infrastructure.
Yeah, for sure. We can look at it. You know, the way the equations were written, it's really remarkable. Actually, if we get the one on the proton where you can see the little fluctuations of the, there it is.
Okay.
And, you know, you don't have to worry about the equations too much. Basically, those are actually very simple equations. They just describe the surface to volume ratio. And so basically, I pixelated, they're voxel actually, because they're 3D, they have volume. But you can think of it as little pixels. I pixelated the surface and the inside, the volume of the object, and found how many there is on the surface and how many there's inside, and what is their energy value. So you could think of it as like, if you have these vacuum fluctuations everywhere, and basically the proton is a knot in the vacuum. It's like a little focus point, a little vortex in the vacuum in that region. All we can say about the proton is that there's a charge there. We know it's not like a billiard ball, right? So it's a charge in the vacuum. So then I calculated how much energy there is in that charge in terms of these Planck vacuum oscillators. And turned out that it was exactly the mass of the universe, or the mass of all the other protons in the universe was
Wow.
present, in terms of information in one proton. And then that, like really talked to me of the holographic nature of reality, where, yeah,
Good.
where information is, but imagine all this information present inside the proton in terms of the vacuum, but the surface limits how much the information can move across that boundary. It's like a bug rate. So then I did the ratio between the surface and the inside in terms of information, and I got the exact gravitational solution from that.
Wow.
And it was just remarkable.
And now I see two things here. First is this, geometry,
Yes.
that we see there. And I think, it's pretty amazing because that geometry link with the tetrahedron kind of structure.
Absolutely.
So is it explained, because sometimes we speak about non-locality, information. We had an experiment done a few times ago online, and we were speaking about, intention that is carried on in non-locality.
Right.
So now we can think that this geometry, organization inside is the carrier of the information.
Exactly. And now it makes sense how, like, really esoteric things that occurs, like, that seem magical, that seem impossible, like remote viewing or, remote healing, all these things, you can start to see, oh, this could be the mechanism how this is possible. If all the information of all other things in the universe is present in each proton, and you had access to that because you're made out of protons, right? Then you could remote view. You could have the information of something that's on the other side of the world that you're not, able to see with your own eyes, or but if you access that information, you could do that, and and starts to make things that seems really esoteric and really impossible. Now you start to see the possibility of it, and as well things in quantum theory that didn't make so much sense neither, like entanglement, spooky action at a distance. Einstein called it. Yeah, like why does a particle here, when I change its state, this other particle over there changes at the exact same time? Well,
because all these protons are interconnected together.
They're interconnected. Nothing is ever isolated from anything else.
Absolutely.
Because this field is connecting everything together.
So in other words, we have now in some way the mechanic of what previously we call, let's say, non-locality or innate intelligence. And I like to bring here now this this slide about the cell division, which is another challenge in biology.
Right.
That we try to explain toward the morphogenetic field. I don't know if you can. Yeah, this one here.
Right.
That we try to explain to the morphogenetic field or concept of epigenetic.
Right.
But you come with something which is a little bit step further, where even through this cell division, you were able to show this fractal organization of the life.
Yeah, that's right. This fractal division of the geometry. Now you find it, this was at the quantum level, right? Actually, it was at the Planck scale, which, what we were looking about.
Very small.
Very small.
Very small.
Because imagine for all the Plancks inside one proton to have the mass of the universe, you got to imagine how small these bits of information are. It's incredible. If, just to give you an example, if you were to grow a proton, a Planck, right, so that it would be the size of a proton. So that just for people to imagine the size of a proton, you're made out of about 100 trillion cells. Each cell is made of about 100 trillion atoms.
Oh, wow.
And so, and the proton is a teeny thing in the middle of one atom. So already, like, it's small, right? The proton is really small. But imagine that you grew a little Planck, which is the fluctuation of the vacuum thing, and you grew it to a proton, then all of a sudden the proton would be from here to Alpha Centauri, right? From the sun to Alpha Centauri would be the radius of a proton. So that's a difference in scale, right? So then, but when you go from the proton up to the biology, then you can see that same division of the structure of space occurring at the biological level, the way cell divides as we were looking at them. And you know, the solution at the proton level is only true if you look at the geometry of the Planck doing that very specific pattern. If you put it in other patterns, the solution is wrong. It's only true if the fluctuations of the little Planck are space filling, so that each waveform has to overlap each other and create this flower of life kind of structure. And so, and you find it the way the cells divide, and you find it, you know, everywhere in nature, the way biology self-organize. And this is a big problem that we're trying to solve for all these years as well.
Absolutely. It's like, you know, here we have it's kind of layout, some principle of quantum physics in biology. Now you do the step further where you add this fractal information at the core of every protons.
Right, because current quantum theory and relativistic equation don't have biology in it.
No, absolutely. We have to stretch there.
Right, because it doesn't predict the organization we see in biology. In fact, it predicts the exact contrary. It should not happen. It's the fact that even one blade of grass with all the bacterial life and all the DNA in there exists after only 13.7 billion years since the Big Bang is a remarkable thing. If you do the statistics of that, it's very, very improbable that this could even happen, you know. So there must be a mechanism that has this fundamental self-organizing structure, you know. And in order for things to self-organize, they have to have some kind of feedback, right? And that is what I was, when I found the proton mass, you know, the fluctuation of the vacuum inside the proton mass, and then the Bog rate of this information going through the surface, right? And then going to the vacuum. So the information is moving from the inside of the proton through the surface to the back to the vacuum, and the vacuum is moving back into the proton. And the equations showed this relationship. And so there is an exchange of information between what's inside and what's outside. You know, a little bit like our experience every day. We, you know, interpret what we see outside of us. We, you know, make an interpretation that dictate our actions, like a cup is there, so we want to grab the cup. And then the universe feeds us back, you know, the experience of our interpretation, and so on, in this continuous feedback. So if there is such a feedback at the fundamental level of creation of this field, then that is what can create that self-organizing geometric fractal structure that we see everywhere, and eventually in biology, and even a human being emerge from it.
Yeah, I like we bring this picture where we have the double torus. Can we see that this in some way express what you just said, right?
Exactly.
Because we can see, okay, here, this is pretty good here. You know, this kind of movement inside, this is what you're saying. So again, and then the energy move outside, which is, you call horizon.
The event horizon.
Event horizon. So when you are within, it's like, you know, this is where is the core of information. The feedback is when you have all this movement in and out, right?
That's right.
Can we can visualize this way?
Absolutely.
And can we see the proton with this model?
Absolutely, because the geometry I'm talking about is not static. It's dynamic. It has spin in it. And when it spins, this tetrahedron structure, when it spins, it produced a movement outside and a movement inside, which produced this toroidal field. And this fundamental torus allows information to go from the inside to the outside, back into the inside. So it's a constant feedback loop of information. So the system actually learns about itself. It's
Absolutely.
evolving.
So, and we can also picture the universe the same thing.
The same
It's
way.
like you have this minus little protons,
Yes.
which we call a black hole, right? And the
Right.
whole universe is also, shaping this way. Instead, we see this kind of model where you have a big bang and everything is going apart, and then should be imploding. But they didn't figure out this kind of organization.
That's right. There's more and more evidence that, like in background mapping of the universe, that the universe may be a torus, and that means that it can have expansion and contraction, at the same time.
Absolutely.
And so that it's a metastable universe in which there's matter production. I think that it's really interesting that just recently they found one of the lost papers of Einstein, a paper that had been overlooked, that he had published about and in this paper he was theorizing a universe that's constantly producing matter and expelling matter, so that it's constant dynamic flow between creation and expansion. And it's really interesting because it kind of matched nicely with some of the evidence that are coming out at this point. And the way he wrote the mathematics was problematic, but if it was taken and rewritten with what we know today, I think there's a really, really good chance that that model is more accurate, that the idea that the universe just did one bang and that's it, that it's a continuous creation model instead of just one creation dynamic. The other thing is that from this new view, creation of matter is not some miracle that happened 13.7 billion years ago in the Big Bang, right? Which is not explained by the standard model. Like, where did the matter come from? Where did the energy come from? Now we start to see, wow, there's this field of information that's the source of matter creation. And then the source of the organizing principle that eventually produced biology, and that eventually produced even consciousness, because basically our brain is this network of information as well, in our body and so on, that's communicating and self-organizing. And it's based on feedback, right? And so self-awareness is a feedback structure.
So this is where fit mind and consciousness in your model.
Absolutely.
Yeah.
So that you can not only unify cosmological physics with quantum theory, but you can unify biology and consciousness study and all this, because it starts to come together in a whole view, a holistic view. And this is why I called it black holes, WHOLE, because it's not isolated. It's not a hole that's isolated from the rest. It's actually connected to the whole thing.
Exactly.
Yeah.
And it brings together also, which is there to me, old ancient system of healing. And I don't know if we can bring this slide, Alexis, that we prepare. Yeah. Yeah, there is, if we look in the history, you have all these fractals. If you think in terms of Taoist medicine with the Qi, Ayurvedic medicine, the prana, even natural medicine, they are speaking about vital force. And still, the materialistic model of science cannot have a grasp on that. And of course, we start now to extrapolate with some principle of quantum physics. But, many of these sciences stay a mystery. And then with your system, because now you add this fractal organization, we start to understand how it works. Let's take an example, the acupuncture class we have in the program that relate with Taoist medicine, the I Ching, and the organization. You have some your model can also bridge with this kind of understanding, where we have this model of Yi chain. And I don't know if we can play the video, Alexei, where you know,
There's the I Ching.
the Yi chain, and then you have this model here where you have you
If
know,
you take each lines of the I Ching, of the symbols of the I Ching, and you match the opposite symbol of the I Chings together, you get, in 3D, you get a star tetrahedron structure, which is the base of this foundation for the geometry of space-time that I describe at the Planck level in my paper. So it's really remarkable that that was present, you know, thousands and thousands of years
ago, and this ancient model of healing had probably to do with this kind of information too.
Exactly.
That this is the thing.
Yeah, because the I Ching, for instance, and it was pretty complete, because the I Ching, for instance, was always associated with the yin and yang. And if you look at the yin and yang, now you have the twisting, the spinning.
Yeah, we have this one too here.
Yeah, there you go.
This is very interesting.
Yes. So I realized that when you look at the yin and yang symbol, the black dot is in the white and the white dot is in the black. So it's counterpolarized. So I was thinking, how can the black get to the white and the white get to the black? And the only way you could do it is if it's connected through a wormhole, you know, torus structure, and so that each one has access to the other through the polarity of the field of a torus in 3D, and then when you put it together, you end up with the yin and yang.
This is very fascinating. Yeah. And then we have in Taoist medicine what Marguerite de Suranné called the atomic heart, and is also, I think, kind of an inspiration of the Yi Ching and how this Yi Ching spread. First in 2 here we have the atomic heart, and then, you know, they divide in 8, and then in 12 meridian, 64 I Ching.
Oh, wow.
And at that time, you know, the idea was also to find imbalance. Imbalance related with some behavior or some kind of emotion. So I believe in that time they had probably some way to translate fractals in behavior, maybe. I don't know what you think about that. This is kind of a stretch here, but you know, this come from somewhere, this science.
Right, absolutely, because, you know, if we're made of this fundamental field and it's permeating everything, then, you know, instinctively, we'd eventually, throughout civilization, we'd start seeing it emerge in our traditions and all this stuff. And so I think people, through meditation, you know, which is going inward towards the center of our existence and so on, may have been able to access this field and learn to manipulate it, you know, in healing modalities all around the world. And, I mean, many ancient civilizations talked about the prana or mana in Hawaii.
Mana in Hawaii, absolutely.
Yeah, and the chi and all this stuff. And I think you know, when you look at the proton, for instance, it's the most stable. I mean, no proton has ever been seen to decay. I mean, we collide these things, we do all this stuff to them, and they stay extremely stable because they have this relationship between the inside and the outside that's in a metastable state. So, you know, if we were to philosophically apply that to the biology, when that stability is upset, right, when there's an imbalance, then there probably is a breakdown in the information between cells. I think that would be a possibility for like the source of disease, you know, and other things. Yeah, and like mental illness and all this. You know, that this sense of isolation, whether it's a cell, you know, that's no longer able to communicate properly
with the other,
or a being that feels isolated, disconnected from their peers, and so on, you know, despair, all these things may, you know, you could almost link it back. It is a stretch, but you can almost link it back to this fundamental pattern. And if you if you can bring that to the people, if people understand it and all of a sudden can visualize it and use it in their practice, all of a sudden it may be possible. And as well, I mean, there's incredible application to technology.
Yeah, I'm already looking at this, you know, what you came with, because, you know, it's there is a sequence here. First, we have to come what we call, the theoretical science, and then you have to come with the application of it.
Yeah, yeah.
And application will come out of that, of course.
Absolutely, yeah.
And so again, it's like here, proton become kind of the cornerstone of all this, what you call unified field theory. It's kind of a big task, right?
It is a big task.
Because, how many people want to bring all this together? Even Einstein, he died and he could not have made it. And
he was writing equations hours before he died. He was still trying.
I can be sure. And and now you come with this unified field, and the proton is at like the cornerstone of that. And then, of course, and then we can incorporate so many of these ancient systems of healing too. So again, can you brush the whole picture again? How, what do you mean by unified field? That you.
Right. So technically, unified field theory in physics is specifically to unify the forces between the cosmological side of our equations, which is Einstein's field equations, which include gravity and, as well electromagnetic fields and so on, and the quantum fields, right? So the strong force and the weak force and so on, and to like put them together. But I think there's a deeper meaning to unified field, and some people call it, theory of everything and so on. But I think that it's a unified view, a holistic view of the dynamics. I mean, holistic in terms of whole, view of the dynamics of creation, from the creation of matter to the self-organizing systems of biology, and then the emergence of in that complexity, like when the complexity get high enough, when there's enough information dynamics going on to what we call consciousness of self-awareness, the system becoming aware of itself and becoming able to like experience and examine its own existence. And that it's emerging in many different ways. It's been a huge task, and you can imagine I get a lot of tomatoes thrown at me.
I can imagine.
Yeah.
But you've done your homework, this from what I see. You know,
Yes.
it's not just coming with an idea here. You know, you come with the explanation that goes with it.
Yeah, and this last prediction is really supporting the concepts are correct, and so it's exciting. But what is important is that, like, when you look at this, I mean, what you get from it is a deeper sense of self, a deeper sense of how you were created, and what is your relationship to the rest of the universe and to the whole. And when you realize that, there's all sorts of applications in your life, in your daily life, that are really important. When you think of that table and that chair and the wall behind us and all this stuff, all of a sudden you realize, wait, there's this field that connects me to all that stuff. I'm in constant interaction with all that, and I can manipulate it because I'm part of it. So now it starts to explain as well why the observation of a system seems to change it, which is something that was discovered in quantum theory early on.
Yeah, the observer, is part of the experience, the observer effect,
Yes, that's right.
the way you look at things.
The way you,
So in some way, with what you found is, add a twist to that, right? It's
Exactly.
like, it's exactly what we were thinking,
Right.
but there is something else even deeper.
Exactly.
Can we say that through this idea of the proton gathering all the information,
Yeah, even
Can we say that?
Yeah, because
Okay.
even other that's where I was getting at earlier, is that even other scientists are coming to conclude to things similar to it. Like there's a very famous physicist that just wrote equation in a paper showing that entanglement at the quantum level is actually the result of wormholes connecting the particles at a distance. But wormholes are classical objects, meaning they're from Einstein field equations, right? So, and they're part of black hole theory and Wheeler, another famous physicist that worked with Einstein, had come to conclude that this vacuum energy fluctuation of the quantum world was actually wormholes everywhere, connecting everything. And so this connectivity between all the things, it starts to make you understand that, like, you are part of this incredible dynamic, this will work of nature, that you have an influence on it because you are feeding it information. So then the double slit experiment, which in the Copenhagen interpretation generated basically the basis of quantum mechanics we see today in quantum field theory.
Absolutely.
As well, eventually. But this interpretation that the particles seem to be a particle and a wave at the same time, and it could go through the two slits and interfere with itself and all this stuff, it starts to change. All of a sudden, instead of this double slit experiment becoming like some kind of magical thing that happens that you can't visualize, that you shouldn't try to visualize, it's just the way it is, you should just write the math for it and forget it, and the fact that when there's a measurement made, it changes the result of the experiment. All that it's like floating in the air in quantum mechanics, meaning it's like quantum magic, it's quantum weirdness commonly thought of. Well, when you think about it in the terms of what we're discussing now, in this new view, it makes sense. For instance, when the particle moves, it's not moving in a free field. It's actually moving in a field, and as it moves, it makes waves. So the waves go through one slit, and the particle goes through the other, and you get all this stuff happening that you see in the experiment. But actually, it's just because the particle is interacting with the field, and actually is made of that field. And so if you put an observer there, if you put something to measure it, well, that thing is influencing the field too. So it's going to influence the result of your experiment. And so that starts to make sense in a mechanical way, meaning that mechanical doesn't mean it's boring and it's like gears and stuff. It means that, like, you understand the fundamental parts that makes that
how this works.
Happen. Yeah,
exactly how this works.
Yeah,
and probably the mistake was to think particles are just little balls.
That's right.
And waves are just little waves.
That's right.
Now you come with a model where no, it's not little balls. These are torus of information moving around.
Right.
And then wave are not just this, two-dimension type of thing, but now you give a three-dimensional way to look at waves.
Right.
So it's, in other words, it's kind of, we had, I felt good when I heard about quantum physics, because everybody that were a little bit weird, and thought about non-locality and this and that, we felt good because, finally, maybe I have a way to explain it.
Right.
Now, we get a little bit disappointed because it's not what we thought, but it's even better when you start to look from this angle.
Yeah,
because you get another layer of information, which is about a more dynamic world, and which you interact to, but you can explain it.
That's right.
But at the end of the day, you said, here, I have an explanation, how it works.
Yeah, and you can even prove it to a student or a person, because, like, for instance, I've been saying this for a long time about the double slit experiment, but I didn't necessarily have the equipment or the whereabouts to actually do the experiment. But MIT did, and scientists in France as well. And they took a little back of silicone liquid and they put little silicone balls on it, and then they put the two slits, and they fired these little silicone balls that walk on the silicone and make waves and all this, and they got all the same result as the double slit experiment with fluid dynamics. And so this is very supportive of what I just talked about. because we're talking about a little particle in a field that acts like a fluid, that acts like the water in your tub when you pull the plug.
Exactly.
Yeah.
Is there, you brought out a slide or so that you like to share? I don't know if we can come back to that.
Yeah, I think I brought it.
Because the visual help people to understand these concepts.
These concepts,
you know, this morning we really, I would say, pushing boundaries a little bit more.
Yes.
You know, because maybe some our listener are used to what you explained, but some come, you know, for a more, let's say, a more classical quantum physics point of view.
Right, I understand, absolutely. And you know, if you talk to physicists, quantum physicists that are honest about quantum theory, they'll tell you it's incomplete. You know, most physicists will agree to that. And I think that this is maybe the first baby steps in completing the theory. Mm-hmm. And when we do, it's no longer just quantum theory, it's actually the whole thing, meaning it's quantum theory and relativistic equation put together, so that you can take the theory and apply it to a black hole in the universe, and it works, and then you can apply it to subatomic particles, and it works. And so it's really kind of able to like bridge, or you could apply it to the biological resolution, the fractal level of biology, and it works too. The same principle are, you know, reproduced from one end to the other, and why not? I mean, there's no reason that there would be an interruption or discontinuity anywhere in the universe.
Exactly.
It must be the same mechanics that function at all levels, and that's why Einstein was saying, you know, we have to figure out a way to connect quantum theory with relativistic equation.
He didn't like it at the beginning.
No, he didn't.
I don't think. Yeah.
Yeah.
This is what
Although
I
he
heard.
was one of the person that started quantum theory, he didn't believe the universe was a result of some random fluctuation with no heads of tails. You know, his famous statement, "I'll never believe that God is playing dice." You know, like that it's all random, and you know, and this fundamental structure. He even made statement that when a unified field would be found, it probably would be fairly simple. And that's one of the criticism I get from my peers, is that it's too simple.
It's too simple, and you get rid of the strong and the weak force.
Right.
This is, you know,
Yeah.
taking out of the park some toys they were playing with it. So
Sacrilege. So and as well, he said that it would probably be a simple or an elegant algebraic geometric solution, and that's exactly what was found. So I think that you know, it has some merit.
yeah, and he said something too that has made me smile. You know, when they prove that his theory was working, one journalist asked, you know, and what's happened if it will not have been proven? He said, it cannot be possible because it's too beautiful.
That's right.
It's too beautiful.
It is.
That theory has to work because this is beautiful. And you said you are saying the same thing.
Yeah, I mean, imagine that. I get gravity from the surface to volume ratio of little fluctuating vacuum entities. You know, it's a simple equation. It's just basically a ratio between the number of oscillators on the surface. So imagine the surface oscillating, and the number of oscillators on the inside, and then I multiply it by the Planck mass, which is the mass of one of the oscillator, and you get the exact gravitational force.
So but at the end, what generate all that spin and all this gravity
Yeah, that's a good question.
so where this come from?
Right. Well, you know,
Where's the source?
right. What is the source? Yes. Well, that's a big question. Well, you know, just like when you pull the plug in your tub, you create a gradient.
Yeah.
Because there's a change of density between the air in the drain and the water. So the water goes down and the air comes up, right?
Okay.
When you look, so
who pulled the plug?
well,
One day you ask, who is the other side of the balloon, right? You know, when you blow the balloon?
Yeah. Well,
now, who pulled the plug?
Who pulled the plug? Well, if you So maybe it was always full, meaning it's an infinite plug. You know, if you have, so the density of this energy, the vacuum at the quantum level is really, really high. It's like 10 to the 93 grams per centimeter cube.
Boy.
Yeah, it's more energy in a centimeter cube of space than if I put the whole universe.
Yeah, we have some slide
We
on
have a
that. I like
slide.
I like
I
we
think
go
it was
there.
the first
Can
slide
we
of my
come back to the
presentation.
PowerPoint where we see the density, this
of the-
cube, you know, where you pack all these.
These little plonks in it.
Yeah.
So here you see that like the cube on the right there with the little blue balls.
Okay.
Each one is representing a plonk. Obviously, it's not the right scale, right? The plonk is teeny, but they all have approximately 10 to the minus 33 centimeters in radius, and you know they.
So in other words, if we pack a centimeter cube with the smallest
entities.
entity
Yeah,
that
yeah.
has been approximate.
Yeah, from
calculate.
the electromagnetic field. It's the smallest vibration of the electromagnetic field that's possible.
Okay,
Right? The
yeah.
smallest photon. If you pack a centimeter cube full of these things, each one is a little energy, so it has a mass, right? E equals mc squared. It has a mass of 10 to the minus 5 grams. And you calculate how much mass energy of little plonks there is in a centimeter cube, you get 10 to the 93 grams per centimeter cube. And if you did the same thing with all the stars in the universe, all the galaxy, everything we see in the universe, and you stuffed it into a centimeter cube of space, you'd get 10 to the 55 grams per
Not
centimeter
even
cube.
half of that.
Right? Oh, no, not even close. You're 39 orders of magnitude off.
Oh,
You
boy.
know, so that is like it is a huge difference because when it's exponential, right? When you add zeros, it gets bigger much faster. So,
Oh, yeah.
So you can imagine that the vacuum density at the Planck level is at the quantum level is really, really highly dense, but at the universal level. So if I take a proton with all that energy in it and I grow it to the size of the universe, I get the exact vacuum energy we measure in the universe. In the universe, we call it dark energy. That we see in our universe, and that's 10 to the minus 30s.
Yeah, and we have
grams.
another graph with that, the curve, where we have a graphic, you know, where we see
Right.
the protons, and then you have the smallest unit. And
That's right.
Maybe it's next. Can you move the slide, Alexei?
I don't know if I had this in the presentation, but you might have pulled it independently from the net. But in any case,
No, not that one.
it was a graph showing the different masses in the universe.
Okay, you can stay there, Alexei. We'll speak about that after. Yeah, but you know, it's like here you have the whole universe, you have the smallest units, and then the proton is like at the middle of the chart, right?
Right, exactly. It's in the middle of the chart, and it and when you do the proton with my equation, it lines up with all the things in the universe.
Exactly.
And when you do
Because
it,
they done some kind of normalization, and then they know the proton was out of scale.
well, yeah, because they didn't calculate the energy it takes to do the strong force. So if you take just the mass of the proton and you don't calculate the energy it takes for that proton to produce the strong force, then you get the wrong idea about the energy of the proton. And because they just threw in the strong force without saying where the energy came from, they have that deficiency. And so I repaired that using this holographic view, this geometric view. But I think we were, so you were asking where is that
Yeah.
why is it all spinning? Like how is it, who pulled the plug? Well, you know, the density change between the universal size energy level of the vacuum to the Planck size is huge. So this whole thing is like driving this spin, you know, because the plug is perpetually pulled.
Yeah.
So everything is continuously spinning like the snake chasing its tail, you know, trying to resolve this change in density. So you could imagine our universe is in a larger one, that's in a larger one, and all these have different density vacuum structure. And so the Planck pixel I'm using is only true for the scale of universe we're in today. You see, that in a larger universe, that Planck pixel might be much bigger for that universe. You see what I'm saying? I mean, for that universe, our universe might be the pixel. Do you see what I'm saying? So there's a constant change in this infinite fractal structure of density gradient that's driving the whole information network. And
So it's very, it's some, I can't figure out what it's speaking about, but to imagine when you speak of this degree of mass or degree of this, it's very hard for the mind to just figure this out. It's almost impossible.
It takes some gymnastic of the mind.
Yeah.
I've been going at it for 30 years or 25 years, so I'm kind of used to it. I forget how, it can be a little difficult. It can hurt a little bit, but it's only temporary.
Yeah, a little headache, right? And now we see the fractal inside structure.
Yeah.
And then I think through your exploration, you find these fractal structure in
galactic structures and supernova.
Supernova, but I mean you let's say the flower, the what is the name of this one? You find this on temple and all this.
Oh yeah.
There's a
that's
link
right.
with ancient civilization.
Oh,
too.
absolutely. Yeah, absolutely. The ancient civilization had this type of geometry everywhere in their temple, in their text. Even Da Vinci was drawing it everywhere. You can see here on the food dog, and the food dog in these traditions was considered the guardian of knowledge, and the knowledge that the food dog was guarding was under his paw, right? He was guarding the knowledge, and you look under the paw, and what do you have? You have a sphere with these, pixelation structure right on the sphere, which is the exact solution to gravity that I found. I mean, it's remarkable, and this stuff is thousands and thousands of years old. So maybe they were trying to tell us something really, really deep about the structure of creation, because they didn't think of these as nice artwork. They thought of this as very sacred art, very important. They were the basis of their teaching about the structure of the universe and how things work. And maybe they were right, because the math comes out right for it when you use this kind of geometry. It's remarkable. It's remarkable. And when these guys talked about, even in those traditions, especially in the Chinese tradition and so on, and in the Taoist tradition and all this, when they talk about influencing the qi, working with the qi and influencing the qi and all this for healing purposes, or in martial art and all this stuff, they do incredible things that you don't think is possible, that have been documented. Maybe if you're able to visualize the geometry, and if you're able to get in this zone,
space,
in this space where you're connected, where you feel the connection, right? Maybe you can influence it and make things happen that you wouldn't think would be possible in other cases, But as well, it leads to technology, because we may be able to do that technologically as well. We may be able to actually learn how the field interacts and pull a little plug in a little region of space to get a little control over gravity over here. And all of a sudden it could lead to gravitational control, energy production, in health and wellness and life longevity. I mean, all these things.
Yeah, now we open the door to application.
Right.
And this is where already some people are also experiencing with crystal, because crystal, in some way, you can imprint these geometry.
Yeah, crystals have very highly structured molecules. Typically, they're tetrahedral, hexagonal geometry.
Exactly.
And so all of a sudden, water molecule is the same. All of a sudden you see, wow, water can be influenced, crystals can be influenced. And if you do these technologies, and some of the experiments I've done already, we're using crystal and plasmas together and all this stuff, there is a path to a whole new...
I can see that.
Yeah.
Because the idea, when you start to understand how work the field, and not only vaguely, but the structure of the field, And then you can think of disease like unbalance, you know, or disconnection, you know, using this different technology, working at a more subtle level, can reorganize the physical aspect.
That's right.
This is probably where we are heading in the next in the next
Century.
decennies.
Yeah,
I would say decennies, very close to that maybe. We know.
Yeah, absolutely. I think we're actually not far at all, because we have the technology today, meaning we have all we need. If this is true, and now we have the math, so that so it's very precise to do the engineering. I think we're very close.
For me, it's very exciting.
Yeah.
Because in some way, what we use to restore health now, the materialistic model we use pharmaceutic, which is pretty far of, you know, to restore the perfect model in some ways. And then we use herb, plant, which is good also, which is more a natural version of pharmaceutics.
Right.
And then you come with the homeopathic, which is also very interesting.
Right.
You know, dilution, and then you have more...
Water is involved.
Yeah, we have more an informational, I would
Medium.
say, medium.
Yeah.
But still, you know, you have to adjust this information with the imbalance. I know how complex is homeopathy. Now we are getting even deeper, where you say, here, this is how universe works. This is the perfect information at that level. This is how the whole universe is organized, with this fractal organization. You know, you call that the 64-grid tetrahedron.
Yeah.
And we have the model there, if we can come back. Now it's like you have the perfect blueprint in some ways.
Right.
So
when things are in balance.
So let's look now for the technology that will bridge, you know, our little tiny physical aspect with this core of information.
That's right. Because, I mean, a lot of the issues that occurs in biological structures had to do with, you know, information, disconnection, you know, areas. In one way, you could think of it as areas that lose resolution, that lose coherency, like they become somewhat...
Yeah, I like that too. Coherence.
Yeah, they lose coherence, right? Because, like, for instance, if you look at, you know, the water in the body is typically highly structured, right? Highly coherent and highly structured. If you look at cancer cells, the water in there is very incoherent.
Disorganized.
Disorganized.
Yeah.
And so if you have an influence on the field, right, that creates coherency, that generates high coherency in the water structure in the first place, you know, and everything else, then if you can beam that coherent, like if you can create a coherent environment, then that water can become coherent again.
Exactly.
And now you might be able to have a large influence in that disease, on that disease, so that everything goes back to balance.
Absolutely.
Yeah.
And we are doing already some research. We spoke about this previously with quantitative EEG, you know, brain mapping.
Yes.
Where we can see incoherence and coherence and, you know, different type of waves. And when people absolutely are in a coherent environment, you know, they can restructure health. But,
all right.
So, but,
right.
you know, now it's like adding technology to that.
Right.
Because
like an amplifier of coherency, you know, like it would be, it could be really, really powerful, you know, and so it's really an amazing thing. You could think of the brain, you know, instead of thinking that consciousness is in the brain, you could think of the brain as like an antenna, like a radio set, tuned in to certain frequency of the information structure of the vacuum. And so that everybody's tuned into a little bit different frequency. That's why we're all a little bit different, because we observe the fractal from our position, so we get a little bit different information than anybody else. And so we're tuned into that frequency, but then sometime our radio set is a little bit off. You know, it's like, you know, when you're tuning your radio, like sometimes it's clear and then you go a little bit off and it's like, you know, there's a lot of noise, right? So when the brain goes into coherency, it's just like a radio set. I mean, if you look at the oscillator in a radio set, when you go into resonance of the sync circuit in there, it becomes no noise, right? And so the brain is acting a little bit like that. And I'm doing research with William Brown, Dr. Brown, and others that are mapping the microtubules in the brain and how like these things could be like teeny antennas. They're little tube, you know, vortex structure that have water in the middle of it, like and all this, and how this could be like the antenna interacting with the vacuum and the information moving through that antenna. And some work was done previously by Penrose, a very famous physicist, on it, and as well. Yeah, so it's not new, but we're with this new model, we may be able to bring it to the next level, so we become more and more clear, so we can apply it better.
Absolutely, I can already see a lot of application in healing.
Yes.
Is there other slide you like to comment for the presentation?
No, I think we've gone through most of them. I think that, you know, if I don't think we had the torus in an animated way, but I think people can visualize that this information is in a toroidal field, so that they can see that, like, they are feeding information to the vacuum and the vacuum feeding back information to them. I think that's a really important thing, because there's a lot of talk these days about you're creating your reality, you know?
Exactly.
That you're the one that's shaping your world. And in one way, this is telling you that's true. That not because of the double slit experiment and the Copenhagen interpretation, but because the field is an information field that you're interacting with. But what it's telling you as well is that it's feeding you back information too. So that it's not just you creating your reality, you're part of a larger and actually infinite fractal realities, but your fractal probably has the most influence, like the global consciousness, you would think, like the morphogenetic field.
Interesting.
Of the global.
So you know you have in your model, you have to not take care, but be aware that there is also other creator out there, right?
That's right. You're not the only one.
So this is why maybe sometimes you are off, you know, when you want to create something, you have to be aligned with
the higher purpose.
The higher purpose.
Yeah, the larger fractal community of the information that's moving through, so that the systems can self-organize. Otherwise, it'd be complete chaos. You know, somebody.
Interesting.
Yeah.
I like that this idea, because there was something kind of realistic. You know, of course we have a, you know, we are kind of master of our life and so. But you know, how we can integrate this in the bigger plan was not very clear with the other model. I don't think so.
Right, because yeah.
And then when, let's say, you know, when someone is doing meditation, you know, go within. And then, because now you're more in within the structure, right? In some way, you are at the core of the information. Can we see this way, or?
Yeah, absolutely.
So it's like, you know, here you are within, without, and then when you are without, it's like you are what people see and what is your life, and you know.
So that's like the surface of the event horizon, and is the without.
Sure.
And then within is the volume information, right? And so you're transferring information between the out and the in, and interpreting it and sending it back. And so those things are really kind of, you know, you start to realize that information, right, like all the greatest discovery, they didn't come from without in general, right? Meaning, there might be precursors or hints that came from without, but generally it's because the researcher had a gut feeling, an instinctive feeling, something. You know, Einstein talked about it. Many, you know.
Yeah, Dr. Goswami speak about quantum creativity and.
Right, And so
It's like an insight, you know, it's a
Exactly.
aha moment.
Right. And we even call it insight
Mm-hmm.
because it comes from inside
Exactly.
us.
Yeah.
And so that's the link,
Mm-hmm.
to the universal consciousness, to the universal information network. Literally, us going towards the proton, going towards the inside of what actually makes us. And then there comes another unification, right, in this
Mm-hmm.
view, which is the unification between spiritual people that tend to think it's all within, and scientific people that tend to think it's all without, that
Mm-hmm.
we don't have anything to do with it. And so now you can start to see, oh, actually it's together.
It's a dynamic model,
It's a dynamic model.
within, without, and then this.
Yeah,
Yeah.
feedback structure. And so when you go within, you all of a sudden have access to information, and deeper you can go, more information you can get, right?
Mhm.
And so eventually you can have people that all of a sudden talk about, like these masters that talk about enlightenment, where they felt like they could answer any questions you could throw at them in the universe and all this stuff. This sense of unity with the whole universe. You're like this little bitty thing on the surface of this little bitty planet with the around this little bitty sun relative to the universe and all this, but you still have this feeling of connectivity with the whole thing. It makes sense because if you go within in that point, you can
Singularity. You connect with the whole universe.
Yeah, you plug in. It's
where
like,
all information is.
right. It's like getting on the
Absolutely.
net.
Exactly.
And we may be able to reproduce that technologically, so that we could take the information that's over here and send it across the other side of the galaxy over there without having to go between all the points in between, because it's already all connected. You see, so like
Yeah, this is fascinating.
yeah,
It's absolutely fascinating.
it's exciting to see
Yeah. And I like to
future.
see research done in our university, and this is what you are doing in some way with your resonance project. Yeah.
Absolutely.
Yeah,
We have
yeah.
a little research park. We're doing, advanced research in theoretical physics, but as well in application, to like try to bring this to a practical application in terms of technology and energy production, gravity control, and all this stuff. I think it's critical for our planet right now.
This is what it is. This is what the way I see it too.
Yes.
I see it also in medicine.
Mm-hmm.
We cannot just, make sense of a health care that has two resources of healing, which is surgery and pharmaceutics.
Right.
It's like to say here today we have this crisis of energy, and then we will not access the other source that we know, gas and
Right.
wind and all this.
Right.
And it doesn't make any sense.
Mm-hmm.
Our mission at the university, this is what it is. It's to open all these alternative of healing that previously was said, oh, it's non-scientific. It's not teach in university.
Right.
Even though now we can see some application of some model of healing, but it's not door wide open.
Oh no, for sure.
And this is the idea, to create a curriculum that can substantiate, that can give a foundation to this model of healing. And I think the information you bring this morning is really important, because it's like the step after.
Mm-hmm.
You go in the mechanic of it.
Right.
And then what will, and this is what I can predict your thing, right? This, as soon we will have application of that. Because at the end of the day, in healing, the one who heals in some way is the one who is right.
Right.
and people are just looking for that,
Mm-hmm.
and we desperately need that in our domain
Absolutely.
of healing. I was hearing a conference a few days ago about the fact that America will be self-energy sufficient in 2-3 years. That's incredible. This is because now they found the gas, so we don't have to
right.
import anymore this kind of petrol.
Right.
And I just wish we do the same thing with health.
Right.
And it's a very, what we just spoke about is very, for me, it's not only exciting, it's inspiring.
Thank you.
And now we have to take some questions,
Oh, yes.
because I'm sure people want to hear more about what you have to say. I like also, before we start this time, do some, information about what is happening with the Quantum University. We have a congress in October 6 to 10, and I think we have some slide about it. And it's time now to sign up and register, because time is flying, and if you want to have a hotel, a good price, a flight, a good price. And this year, the subject will be mind over matter, over medicine, and I think you will fit very well in this group,
Oh, thank you. Well,
because you could absolutely animate the discussion, among physicists, and I'm asking also this question this morning, do you want more of what is speaking Nassim Haramein? Do you want more of that stuff? And yesterday we were speaking also about what you're doing. You're also doing course and seminar, and
yes,
and
we're starting an academy.
And Quantum University will be absolutely pleased to give equivalence for your program. So
wonderful! Yeah,
I won't make this. I don't know. We discussed this just at the table, but I think it makes absolutely sense, and people. It's also to complete the fact that people who will sign up in our program this month will have free seat, for the Congress.
Oh, wow.
So it's time, you go on our website, you can contact an academic advisor if you are interested in the program, or you can also plan for the Congress, which is an event now that we host for over than 10 years, the origin of the university. Mm. And what is nice is people gather together. We had last year people from 20 countries, and it's like a family.
Yes.
And then
that's great.
It's like, everyone reinforce each other, and they have also they are doctors, they practice this modality, and they exchange the information about how they work. And the theoretical model that sustain, what they are doing is, I know this because I'm, building this university now for years, is so important. Because it's like before these people had the intuition, they knew things, they intuit things. Mm-hmm. But they go around and people say, oh, what you're doing is non-scientific, doesn't make any sense, you are doing voodoo, all kind of... Yes. Now we have a model of science that can give a ground of what they are doing. So it adds professionalism, confidence in what they are doing. Right. And the peace that you are bringing this morning, I think it's absolutely very important. Critical, because we do this extra, I wouldn't say mile, but extra, where we can reach more this ancient model of healing. Because at the core of that, there's a lot of information that still was in the air. We spoke about the I Ching this morning. We can speak about, Ayurvedic medicine, the chakra too. There's so much there that stay just in the air at quantum physics, the way it is now.
Kabbalistic tradition.
Yeah, Kabbalistic cannot explain. Yeah. Now with this sacred geometry, this tetrahedron, where you made a 64 grids, and the way you come with it, and you explain also how work the torus. It's like this is kind of the missing link, and what is impressive, we were speaking this morning, and you predict at least 80 events, And now this article is like, you just nail it. There's, after that, they have to do something.
Right.
They cannot just ignore you.
Well, they're doing a pretty good job at ignoring me.
No, but, we will be here at the university, if you want to come back.
Actually, there's more and more scientists that are coming to my side and are excited about it. Very proficient physicists from around the world. It's still tentative, it's difficult because it takes a little bit of time. It's a big boat that we have to change the direction. So
tell me about it. Yeah, absolutely.
So, but it's coming along.
Absolutely, and there is a collectiveness all over the world that go in that sense.
That's right.
And there will come a time, this is what I say sometimes, I'm writing a book now, you cannot stop that anymore.
That's
because
right.
truth is there.
Right.
And then the result will come with it as soon we do application of that.
Right.
So,
And people recognize that. They naturally will recognize fundamental truth, and this is why things like E equals MC squared, became something so clear and so popular, and because it's like, oh yeah, like that feels right, energy equals mass, speed of light, and so on. Now we're getting like, but what is mass? What is energy, and so on and so.
And this is one question here. Then we have very technical question. You will see our listener.
Right.
So from Eonar here, what is gravity? What is heteron energy, vortex mass, and what is sound? Is it a mechanical radiation or an electromagnetic one?
Oh,
That's
okay.
It's kind of tough one, right?
Yeah, there's a lot of
you
questions.
answer that
in
question.
Thank you. Well, that's a good question. Okay, well, what is gravity? As I've shown and shared, gravity is actually the dynamics of this vacuum fluctuation of this information moving in a coherent matter in a region of space, so that, just like the tub example, if you put your rubber ducky on the other side of the tub, the molecules over there in the water, they're like incoherent, they're just going like this and all over the place, so your rubber ducky is not going anywhere. But if you put it close to the vortex where the middle of the tub is, well, then it starts to orbit, because the molecules in that region are all coherent and they're organized in that vortex structure. So gravity is a region of space, and actually mass is a region of space where there's a coherency dynamics in the structure of the vacuum in that region. So that's what I proved in that latest paper, and it works out from cosmological object all the way to atomic structures. So that's kind of cool. What is
this is the
energy?
other question. The mechanical radiation.
No, the hadron energy,
Okay.
the vortex mass. Yeah, well, that I just explained with the vortex, right? It is. That's why vortex math is so important. That's why Schallberger, which was an incredible scientist during at the end of the Second World War and so on, that showed that the vortex dynamics in nature could be applied in all sorts of engineering ways to like create amazing things. And then there is mechanical radiation. What is sound? Is it a mechanical radiation or electromagnetic one? Well, it depends. In some ways, you could almost regard electromagnetic radiation as a really high frequency of sound, reverberating in this information structure. And this is definitely a part of more study I have to make, and more, and it's just non-ending.
I'm
right?
hearing something new now.
Yes.
Sound?
Well, because not necessarily sound, but the electromagnetic field and how.
Because it's a vibration.
Yeah, because it's a vibration.
Okay.
And in this model, it's a vibration of the field of energy. So you can imagine, like, you have a vortex here and you have an event horizon, and if you were to like make this, like if you look at the surface of that event horizon, you could see like this membrane is vibrating very, very rapidly at the Planck level. You can imagine that interaction of all these waves creating the electromagnetic, field,
okay.
and it would have a fundamental resonance frequency, right? It would hum like at certain frequencies for different, and so it's literally like the music of the spheres, from different scales.
Wow.
And so I've been starting to play with these math, and I've been starting to think about how to express it mathematically, and there's more to be done, but it's already coming out with really cool stuff. Like for instance, if I calculate all the surface of all the protons in the universe, right? and then I calculate all the information that's on there, and then I calculate the information that's on the surface of the universe. If the universe is this big bubble with the radius that we observe, then we find that it's a one-to-one relationship, meaning like all the surface of all the protons in the universe have, every Planck has an analog on the surface of the universe, right? So it's like a harmonic relationship. And so there's all sorts of applications to that. So, you know, there's more to explore there, that's for sure.
And some people who read Bible will like it, no? It's St. John Gospel.
Oh.
Au commencement, you know, like at the beginning of the world was
the sound, the word.
The
right?
word, the logos or something.
Yeah, absolutely. This like fundamental vibration.
Yeah.
So it kind of comes together.
And then this other one here, can you speak about the vortex mathematic? You went through this in some way. Do you want to say more about that? Because you spoke about the vortex now. I don't know if you want to say. Yeah, because you've done the calculation of that. And this is how, through doing this calculation, you were able to explain or take it out the strong force, right?
Right, exactly. So that this, the way the information is spinning. So like you can imagine at the event horizon is spinning at the speed of light. So the little proton, you know, is spinning really quick, which is not unusual for, I mean, we know subatomic particles are, you know, have this kind of energy, but, you know, you can imagine like when it's spinning at this velocity, you can imagine that like it's dragging the information in its vicinity, it's moving it, and it's creating these vortex dynamics all around it. And so these vortex dynamics, when you calculate them, when you look at how, because, you know, special relativity, we know now that mass dilate since Einstein when it's accelerated. So imagine you have information that's accelerated near the speed of light, so the mass dilation. I calculated all this stuff, and when I did, it gave the correct answer for the way the strong force becomes weak as you move away from that vortex. You see, so as you move away from the vortex of the proton, for instance, the gravitational field drops very rapidly because the mass of the object dilation is dropping because the velocity is dropping. So it's not just...
So this is why they can hold together.
That's right. And it's why, as well, we can separate them apart. Otherwise, that force would be so strong, we could never separate them.
Got it now.
But if you move it just a little bit, all of a sudden, the force drops so quickly, then it can go away.
And why, when they spread it apart, this was, like you said, plasma, or how come? Because they were expecting something different, right? When they tried to explode the... Yeah,
when they... you're talking about the gluon soup. They realize as well that like when you get into these really high energy experiment, you know, in accelerators, and you get these things to start, you know, like getting more, we get more resolution on how these gluons and quarks things actually operate, although they're never free. And so that's why I'm saying the proton is actually fundamental, because it's the only one that's stable. All the other particles, when you collide, when you break it, when you create it, it's only very short milliseconds when it's... And so, but when they get these soup of these particles, they act like a fluid. And that was unexpected from quantum standard model. So, and the reason why they act like a fluid is because they are part of that field of information. So they actually, they spin, you know, they make these vortex in the cloud chamber, and they act like a typical fluid.
And let's take here another one. What could the mass, vibration, and momentum have a color? And what frequency could they have regarding to the flower of life? Any thoughts? So can you add color to your information?
Yeah.
What could the mass, vibration, and momentum have a color?
Right.
Because now we're speaking about fractal,
Yes. Well,
geometry structure,
yes.
and you have someone out there here. What is the name? No, no names.
Yeah.
Can step ahead and try to bring the colors in that, right?
Well, in one way, what I was just describing about this mass dilation and so on, it's almost like it's like blue shifting. So it has like a spectrum that it, you know, like as it accelerates or decelerates, just like the doubler effect. When you hear an ambulance coming, you know, the sound gets stronger as it gets, and then further it moves, it gets longer, the wavelength get longer. So that kind of thing, you know, so yeah, I mean, obviously, I mean, not necessarily in the visual spectrum, but you could think of it as this whole thing is oscillating. It's like a big oscillating universe. So, but it's not necessarily colors we can see, because our eyes are limited to a
maybe out of our spectrum or something.
outside the spectrum.
Yeah.
Just like if you went all the way to gamma, but then all of a sudden, like, there's that whole new spectrum. You know how before we only thought there was the visual spectrum, and then we discover, oh my God, there's infrared and ultraviolet and all this stuff, and then X-ray and now we have like a larger spectrum. Well, there may be actually even a larger spectrum there.
Absolutely, yeah.
That's right.
When I wake up this morning, there was on the balcony, I saw this nice rainbow.
Oh yes.
Yeah, that was beautiful.
That's so nice in Hawaii. We get those nice rainbow. We get the double ones too. They're so cool.
Another one. You will like this one because you are the first one who said, you know, center of the universe. There is the galaxy. There is a black hole, and then you start to speak about black hole. You know,
physics. Yeah. And
then here's the question: is the atom a black hole? What about the proton? Is there gravitational singularity there? That's key. Very good question.
Yeah, it's a very good question. Yeah, early on, I realized if everything is a fractal and can be divided, then the energy system in every point, since like there's infinite amount of point, or at least to the Planck level for our universe, then everything must have the energy dynamics of a black hole. So I started to look, and I thought, well, it would be the center, right, gravitational center of all the dynamics, the objects we see. So I looked at a galaxy, and I thought, there's got to be a black hole in the middle of that galaxy, right? At the time, that's 25 years ago.
Yeah, that's many years ago.
Yeah, it was absolutely not the case. You know, they didn't think so.
I think you were kicked out of a conference, right?
I was definitely in trouble in many cases and many arguments, because at the time it was thought that black holes were really, really rare, and maybe they didn't exist at all. I mean, and most physicists thought black holes is kind of a weird part of Einstein's equation prediction, and you know, they probably don't exist. And you know, and in some ways, you know, we're coming to see that, like, it's not quite the right picture to think that it's just a thing that's absorbing everything. There's actually stuff coming out. Right? And Hawking just came to conclude that just recently as well. But this, so at the time I said, okay, well, you know, I'm going to predict that we're going to find black holes in the middle of galaxies, in all galaxies, and that we're going to find that the black hole was there first, and then the galactic structure was generated.
Yeah, that makes sense.
And because it's...
Because you have to start at the point of singularity.
That's right.
Right, where there's like kind of a dot at the beginning or something.
Right,
and then
the center of the spin, right? The shaft that everything spins around. And so, you know, because from my view, the vacuum is spinning. The structure of space-time is already spinning. And what we see as the galaxy is just the stuff is in the spin. Just like when you spin your coffee in the morning and it's black, when you take the spoon out, if you didn't spin it too much, you can't see it spin. But then as soon as you put the coffee in it, then you can see. It makes a galaxy, right? And so the same idea is that, you know, the black hole, the spin is in the structure of space-time, and the stuff that's in it makes it visible to us. So then they eventually found black holes at the center of all the galaxies we looked at, and it's pretty well accepted now that there's a black hole, a supermassive black hole at the center of most galaxies. But as well, they found recently in the last few years that now we're able to see far enough that previously from the galactic formation, the black holes were present. So that the black hole is not the result of the galaxy, but the galaxy is the result of the black hole. And so that, you know, those are predictions I made that are, you know, coming through now. And so to answer his question as well, for the atom, what I'm saying is that the proton acts just like a cosmological black hole, where the strong force, it doesn't have the mass of the black hole if you don't consider the energy of the strong force that's holding everything to that proton. But when you do, then you get the exact mass of the black hole. So it's not approximately, it's exact, you know. So there's pretty good chance that's correct, and that you get the right range and all this stuff. But as well, it's saying that black holes are not the monster things that. So when I say the nuclei of the atom, the proton is a black hole, it can give the wrong impression.
Oh yeah, when I heard this first time, I said, you know, I was kind of lost, because you have this kind of picture of the black hole, this monster devouring all the galaxy.
Yeah, sucking everything in.
But, you know, you have to add, and we should look at this online, the torque, you know, the torus picture, because you have to understand this, and this is part of the whole picture, you know.
That's
so
right.
this is how we can
yeah, they're talking about balance. You get a balance relationship between the spin of the black hole and the surface of the black hole, so that you know, when things spin, they pull out. They have centrifugal force. So if you have a balance, then the system is stable.
Exactly.
It's not just sucking stuff in. And even at the galactic level, now they're starting to see closer to the event horizon of black holes, and they're very surprised to see that most stuff actually doesn't fall in, because the spin is high enough that it's keeping things.
All depend from what angle, perspective you are looking at the universe.
That's right.
Are you no, I wouldn't say perspective, but at what scale? Can we say that?
That's right. At what scale, how far you are from the object you're observing, or even if you're looking at the poles, or if you're looking at the equator. So if you're looking at the poles, you might see stuff falling in. But if you're looking at the equator, you might see stuff coming out.
Exactly.
Right.
And here another question. Why there is no article about Nassim, another concept of Nassim in Wikipedia, the Free World Encyclopedia?
In
Wikipedia. But by the way, there is nothing about Dr. Paul Drouin too. You know?
There is? Oh.
Not yet. And maybe I like better not having anything there. You
right.
know?
Well, yeah, lucky you. Because I had some mishap with...
Yeah, I let you answer the question, but doesn't mean this is the reference of everything. You
know,
that's
true.
People have to understand that too.
Yeah.
But, you know...
people may be surprised to find that actually Wikipedia is quite well controlled. It's not actually anybody that can just write in Wikipedia, and it's very edited and censored. Actually, my work is censored in many different matter, you know, in physics journals and all this. I have difficulties publishing and all this because I'm outside everything. So what happened with Wikipedia is that there was an article about me in Wikipedia, and every few days it would get vandalized. Like some person that would get really upset with me, you know, would start writing you know, not with me, but with my theories and all this, would start writing all kinds of stuff about me on that. And it would, you know, like many of the editors that typically edit Wikipedia were putting stuff on there that was incorrect or not accurate. And so it eventually became to a point where the controversy was so tremendous, and there was some reason that they could be deleted, so it got deleted, and then it's been deleted since then, and you know, nobody has dared to try to put another entry there. Eventually, hopefully, it will come back around and it will be accurate. There's a lot of controversy about what I'm doing out there. There's no doubt, and you would expect that.
You know, I have to say my word too, because you know, I'm a physician, and of course, like all the listener here, we are very interested in the stuff of quantum physics, and it reminds me a little bit when I start to study homeopathy. You know, you go to this school. And here you have Unisys, you know, saying, "Oh, what does the complexes? Has nothing good." Or and in this world of quantum physics, people have to realize there is many point of view, many you know, concept. There is a lot of politics, you know, and we cannot avoid that. And someone who has put his little foot in the research, understand how this world is very difficult.
There is a lot of interest.
Yeah. Einstein, some way years ago, didn't have this kind of dilemma. He came and boom, you know, I think that something was very special, because it's like, you know, he made an open eyes to the whole world.
Yeah.
Now this is not where we are exactly.
And he got
yes.
Well, he got the help of Planck. You know, he got the help of somebody that was already very established that said, oh, maybe we should look at this. And then the other people took him seriously, because before that, Einstein, you know, was actually laughed at by most physicists. I mean, they didn't, that time is not constant, you know, I mean,
that was huge what he was speaking about.
Yeah, exactly. So
but since then, many physicists has run with the ball, and they came with all kind of theories, string theory, this theory, this theory. People has to understand that,
right?
And then you come along, and what you put together is like, you know, shifting completely another paradigm.
Right.
And
so it's difficult.
I can understand, you know, it's very disturbing.
It is disturbing.
I was disturbed the first time I look at it, but then you have to look a little bit deeper, and you know, there's one day or another they cannot deny the research and the mathematics of it, and and then you know, one day or another that will be absolutely undeniable. So I'm
right.
sure.
I think so, because you know, like right now, for instance, with the problem of the radius, the proton that they're having, they're trying to find all sorts of ways to patch the standard model to make it work, and it doesn't, you know, necessarily work. And so, you know, here's a beautiful, simple solution, and I think it has a lot of merit, and it will come through. I know it will, and it's a battle. It's a little difficult, and it's normal that it is. People are not, you know, you gotta as well. People have to realize, like in the standard model, there's investments that are enormous.
Enormous.
Over 100 years of physics. Accelerators that, you know, to find the Higgs boson, you know, that have cost $13 billion to build, you know. It's like, oh my God, this guy comes around, we're just going to scrap all this, you know. So it's going to take a little bit of time. And at the end of the day, typically, you know, people may have a knee-jerk reaction when they see this, like, oh my God, it's so outside. But at the end of the day, it's not actually like we're going to scrap all this. It's just, it's the next step. It's actually, it integrates nicely. We just got to realign some of the stuff that wasn't quite well understood, and then all of a sudden it's going to flow.
This is the way I see it. It's kind of the next step.
Right.
It's next step. Yeah. And you know, I can comment about the same thing in integrative medicine or natural medicine. You know, it's the same thing. You know, we don't have the same budget, you know, than has pharmaceutical company. We should do a lot much more research, you know, how to bridge what you're speaking about this morning and other physicists to the domain of healing. We're completely aware of that. And this is why, you know, I thank all the participants this morning to be with us, and because they make the collective consciousness move in that direction.
Right.
And so I have to tell you, we are more far from where we were 30 years ago or 25 years ago, you know.
But that's how long it takes.
So just be patient a little bit more.
Yeah.
Another good question here. The fundamental geometry of space-time basically regulate energy, it's very well said, and information flow. So is it true that human mind is this same geometry?
Yes, I think so. You know, I'm saying this loosely, but you could think of the human mind as a quantum computer that's actually interacting with this field. And I like to think of it as a radio, you know, because it's like a crystal oscillator, you know, like the old radio sets where it had a little crystal oscillator in it. And it's kind of tuned in there into this fundamental geometry, and you can think of it as it is regulated in the same way that is the proton mathematics I wrote or other mathematics, where the vortex flow, the dynamics of that field, the literally, you know, the surface to volume ratio, all these things are important and fundamental to how the regulation of the information is occurring. So you can imagine that if new parts of the brain lights up, it's like more, you can think of it as more surface to volume area. All of a sudden, there is more information that can move through the system. You know, it's like your radio got better resolution, so that now you have like better, crisp, you know, music coming out.
Absolutely.
And so, absolutely, I think that's a really good point. It's a good question.
And I'm thinking about the Congress. You know, I don't know if we can bring this. You know, the work of Dr. Dispenza is very amazing and really fit. It's a perfect fit of what you're speaking about. You know, when the last time I participated to his workshop, he was working with fractal geometry to induce meditation. So we were a group of 300-400, and then, you know, visualizing this fractal. And it's kind of an application of what you just speak about. You know?
That's interesting.
So it's another way to, you know, reorganize the field.
Right.
And Dr. Dispenza will be one of our speaker, and he came last year. And we will do this. I don't know if we will do the fractal one, but I know every year he come and he guide the group in meditation in the morning.
Using the geometry.
I will invite him to use that because it's very powerful.
Yeah.
And it's so the Congress is about that too. It's not, we speak about these concepts, and then we like during the event, you know, that would be 6, 9, 10 October, people experiencing. This is very important. And plus, you know, we will have at the Congress something absolutely fantastic. Everybody that will be participating will have a brain map. Can you believe that?
Wow.
So you want to know how coherent is your brain, and how in the need of doing this kind of fractal meditation is important for you, or so on. Wow. So every participant, you know, will
have their brain map.
Brain mapping, and we will have also a day.
People can compare brain maps and talk about them.
Yeah, and so because we want to make this very, very practical, and grasping the concept you speak this morning, of course, there is an intellectual part of it, but in some way, you know, it's easier when you go in this space within. What you spoke about, and this
and experience it.
And experience it, and this is our event. You know, it's about putting you know, renowned people together, speaking about this concept, but also experiencing. Right. So don't forget, you know, to prepare your flight and hotel and join us. And I like to have a feedback of, how many people would like be interested to have Nassim Haramein there, and be with us. And
It would be my pleasure to
I
be
think
there.
that could be very exciting.
Yes.
It is very exciting. Okay, another one here, and I know the time is flying. What do you think about the multiverse theory, multiverse or multi-universe? People speak about, we have all these movies to the parallel universe and world within world, and from what you said, I think it can fit pretty well.
Oh yeah,
right?
absolutely. Yeah, it depends.
There is no end. No end.
Yeah, exactly. It's clearly, if when you see nature, when you see the natural fractal structure that we see everywhere, and you can see the replication of the dynamics at different scales. I think that it's not a big leap to think of our universe being part of a larger one, and that one being part of a larger one to infinity. That we are part of this multiverse infinite structure. Now, if the person, could be a she, is talking about the literal multiverse theory in terms of what is being said in physics, I think it's partially correct, meaning that the tendency is to visualize parallel universe, and I don't think they're parallel. I think they're embedded within each other.
Yeah, this is more the puppet, Russian puppet, one
Right.
inside another one, another
Yeah,
one.
yeah, the Russian dolls.
Dolls,
yeah. And so more like that. And so I actually was making calculations recently. I'm really excited about trying to figure out like the birth of our universe, like what the thing we're calling the Big Bang, because that dynamic, imagine that dynamics is occurring at the proton level. Now imagine that proton is taken out of our universe. Like imagine that all of a sudden that one proton gets close to the surface of the event horizon of our universe, and it gets pulled out, right, when one falls
Like
in.
a seed.
Yeah, like a seed.
Yeah.
Exactly, like conception. And then...
Yeah, I see where you're going now.
Right.
The seed, the matrix, and the seed.
Right.
Because you define, at the same time, it's like you said, the universe is finite within it, and then the within structure is infinite.
Right.
So now you have one seed that get in another matrix,
exactly.
right? Okay.
Exactly. And now it's experiencing a different pressure differential, a different density in that larger universe. So all of a sudden it would inflate very, very rapidly. So our universe might be one of those seeds that came out from another universe, into that larger universe. Now I'm revealing some of the stuff I'm actually working on, like right now.
Oh boy, oh boy.
And so
we are in the really actual,
Yeah, in the bleeding edge. And so that really kind of, and so far the calculation I made comes out. It comes out right.
Wow.
So it's exciting because it gives you a new idea of the birth of the universe, where you don't just have a Big Bang, you don't know what happened before. Now you understand it's almost like conception.
Conception.
When you have like the seed, that comes out, and then...
And people who read Bible would be happy here because, your work created at the image of God. So
right.
In other words, he's the conceptor, he's the
right.
And the matrix is you have the yin, the yang, the mother, the father.
The father, exactly.
Oh,
so
boy.
we would be like we came out of a father universe into the mother universe, and then expanded to our size, and the math. The math is great because it starts to tell you, like, you can start to extrapolate how many of these universes is there in our bigger universe. And because now you got the scale relationship, so you can work it all out, and so you can actually theoretically explore things past our universe, which is definitely a whole other frontier of exploration.
So tell me, on this kind of journey, or do you feel other physicists that are heading in this way, or
I think so.
I'm pretty sure, right?
Yeah, there's more and
Because
more.
that's, you know,
It's coming along. There's more and more physicists that think that way, that instinctively feel this is the way to go, and it's coming out in many different ways. For instance, there's a popular paper that just came out. It got a lot of press from two astrophysicists called the Planck star, and in this paper, they're describing how a black hole, information structure, actually will go to a certain size, which in and then bounce back, meaning that the information is not lost; it's constantly recycled into the universe, and that paper solves a lot of problems like the information loss paradox and all this, and when you look at the math that was used, the equations I published almost a year prior are in there.
wow.
So and that's because they're using this Planck fluctuation, like the vacuum structure information structure, and so it's coming out many different ways. There's other two Italian physicists that publish another paper along the same lines with using that vacuum. So it's really becoming more and more popular, and the idea is permeating the physics community that space-time is not smooth, that at the Planck level it's pixelated with all these sets of information.
And now, how does he view, or you view, the dreaming mind in relation to waking consciousness?
Oh,
Yeah, no.
well,
You answer that question.
yeah. Well, you could think of our life, as like we were talking about. Like, there's two sides to the event horizon. There's the external side and there's the internal side, and the two are in relationship with each other. And you can like go from the like the information moving across. You could think at the fractal level of the proton, it's occurring really fast, and so when you go further and further from that side, it's slowing down, right? But so you could think of like during the day and during the night, we're going from one side to the other, right? And so what we think of our dreaming state may be actually an experience of the information that's in the structure of space. We're experiencing it in the state of being connected through our inside instead of being connected to our outside. And so...
And reorganizing the information, probably.
Yeah, maybe integrating.
Integrating.
Yeah. And so, so dreaming may not be completely, manufactured from your mind, meaning that, and maybe that's why people have déjà vu, like these, where you dream something that happens in the future, and when it happens in the future, you go, oh, I dreamed of that, and it's so clear, like they had in that moment, like, oh, I could smell the smell, and it all comes, and I know what she's gonna say right now because I dreamed it, right? And it's so exact. This might be because you're actually interacting with that field and actually moving through the timeline in that field in a future timeline, and actually pulling information from a future timeline in that field. That gets a little more complex.
Okay, so when you are within, there is no space-time. You are in this interconnectivity where, there is no space and time. You can access future, or you can be in another place.
There is space, but no time. Meaning that time is a function. Think about it this way. I mean, there's other physicists as well writing papers that are starting to realize that time is actually a result, not a fundamental principle. But I like to think this way. No memory, no time. right? If you can't remember anything, if there's no memory, there is no sequential concept, there's no evolutionary, there's no time. And since we see evolution, there must be an information recording of time, right? Of space, meaning that as you move through space, you may be recording information on the structure of space itself. So, and so imagine that all the information is recorded in this space. That's the information that's moving around everywhere, that's making mass and all this stuff. Now, the ancient, I think they called that the Akashic record in some cases and stuff like that. Now, imagine that, like, this information that's recorded in space is actually able to be translated, right? So that this bit of information and this bit of the information and this bit of information, they have like a vector that is gonna predict a very specific event in the future over there.
Okay.
Right? And you actually access that information from all the bits of the present, and you predicted that event. And so a déjà vu could be this kind of experience of a future.
Yeah, I think I have one of this.
You had one of those?
Yeah, I'm speaking about it in my book.
Oh, yeah?
That should be out, in a few months.
Oh, that's great.
And then
how's it called?
Creative Integrative Medicine.
Oh, wow.
Yeah.
I look forward to it.
Yeah.
Yeah.
And I see the time now is flying, and I'm sure we have to invite you again. I like to have a feedback of people who participate this morning. How they would like to have you in our Congress. I know it's pretty full, but we will see. What's happened there. And I like also again repeat that the Congress is October 6 to 10. Because that will be also an opportunity to do the neurofeedback certification. People are very excited now today to have this technology in their practice or clinic. So we will have an extra day where there will be a hands-on, where they can be certified. And then we will have the brain mapping and all these very renowned doctors. So it's a unique event, not miss it. To miss. And then also when people register in our program this month, they can have a free seat there. So this is another way to welcome people.
Yeah.
And I like also to, we have a slide here on the resonance, which is .is.
Yeah, that is. We picked that, so it would be resonance is.
And I can recognize your logo here.
Yes, yes.
And I think today, it's about cooperation. You are doing an extraordinary work, and we like to pursue this relation of exchange and be at the ahead of everybody about this information. This is very important because at the end, what is it for us? It's translating healing.
Right.
It's translating new technology and a better understanding, how work, these medicine.
Yeah.
And also to provide a scientific ground.
Right.
So
it's critical.
It's critical.
Yeah.
So I really congratulate you for what you achieved, because for me it's huge. It's huge. We speak about it. This article you came with, and I think it will be. In a few years, I'm sure we will look in our library of World TV, and this I'm very honored today to have you on this program.
Thank you. I'm honored to be here.
Yeah.
And I absolutely agree. It's time for everybody to collaborate so that we can work together and increase our capacity to bring this to the world.
Oh, yeah, there's so much work to do.
There's so much work to do.
Absolutely.
And there's so much good work that's being done, and there's so many breakthroughs. And people are transforming very quickly. So it's really good. Like, we need to pool our resources, everybody together, and everybody out there that's participating by being present, by seeing these things, by going to these congress and all this.
Absolutely.
And every bit makes a big difference.
And I want to thank them this morning to have been with us. And I think, we just passed the 2 hours now, so that will be the way we end. And thank you for everybody to have been done with us today. And thank you again to you, Nassim.
Thank you for having me.
Thank you very much.
Mahalo. Hello, aloha.
Okay, bye.